Welcome, guys. Sorry I can't be there with you today. Decided rather than wasting a day, which means we lose a day to review for the final, I'm going to try to give you some notes via a video and a little bit of review of yesterday. If you weren't here yesterday, it was a big day, so make sure that you get those notes from a partner. So first of all, hopefully you can pause this and spend a couple minutes working with your partner to try to draw these, and then I will go through them one at a time. You can pause in between and kind of check what we're doing as we go along. You can see the first one. Let's do the first one together. You can see the first one I've divided up into lines. The lines kind of represent the different chunks of this. The ane says it's all single bonds. Oct tells us that there are 8 carbons. And then this is one big chunk. The 4 tells us that on carbon number 4 there's a propyl group. And you might remember that prop is our carbon prefix for 3. Oct is 8. And then bromo just simply means Br. So this is a bromine on carbon number 3. So if I was going to draw it, I'd go 1, 2, 3, 4, 5, 6, 7. There are 8 carbons there. When you are drawing, it doesn't matter which side you want to number from. Oh, I just realized that that 8th carbon is off the side of the screen. So I'm going to move that one to be over here. 1, 2, 3. Okay, that's 8. And then I'm going to go to the 4th carbon, because it says 4 propyl. 1, 2, 3, 4. And then I'm going to draw a propyl group, which is just 3 carbons. And then I'm going to go to the 3rd carbon and do a bromo. You could have done the bromo on the bottom and the propyl on the top. That's fine. Lastly, each of the carbons needs to have a total of 4 bonds. So I'm going to go through and add a 4th bond, or a total of 4 bonds on each. So if I was just kind of go through and kind of annotate, there's our 3 bromo, there's our 4 propyl, and there's the octane. Okay. Next one. Again, feel free to pause if you need a little bit of time. We've got hexane, cyclo, that means this thing's going to be in a ring. Dimethyl. Now this is an important one. A methyl group is 1 carbon. Di means that there's 2 1-carbon groups. They're separate. They're not together. That would be an ethyl group. And there's a chloro on carbon number 1. So I'll draw this one over here. I've got cyclo. We've got 6 in a ring. It doesn't need to be a perfect ring. Just do your best. But here's my cyclohexane. There's 6 in my ring there. You pick. Let's call this one right here carbon number 1. So that means that I need a chloro on that one. And you go clockwise or counterclockwise. When you are drawing, you get the freedom to pick. I'm going to go counterclockwise just because. And on carbon number 2 and on carbon number 3, I'm going to put a methyl group. Lastly, we go through and we need 4 bonds on each. So I'm going to put 4 bonds again. At the end of those bonds, we know is a hydrogen. And I'm going to go through on each. So there's our, again, to kind of check and annotate. Cyclohexane is there. This is carbon number 1. So that's why it's 1 chloro. And then 2, 3 dimethyl. Di meaning there is 2 separate methyl groups. Methyl because each group has 1 carbon. Lastly, we got 3-methyl 1,2-butadiene. The ene, hopefully you remember, means double bonds. Di means that there are 2 double bonds, 4 carbons. 1 in the 2 refers to where the double bonds are, and then 3-methyl is a group on it. So first, but is going to be 4, if you check your prefix list. Diene, so after carbon number 1 and carbon number 2, I'm going to have double bonds. That's the diene, 2 double bonds on carbons 1 and 2, and then a 3-methyl. So on the 3rd carbon, up or down, I'm going to put a methyl group. When I go through, this first carbon only needs 2 more bonds. The 2nd carbon, it's actually good. It has 4 bonds. 3rd carbon, same. And 4th carbon, I need 3. On the methyl group, I need the 3 bonds as well. So hopefully quick little review from yesterday. We'll go over the homework Friday. So if you have questions on that, we can talk about it then. Name the organic compound. So just a quick naming practice. Again, go ahead and pause it and see if you can name the one on the right. I don't believe we did that one yet. If you're in a class that did the one on the right yesterday, just do the one on the left instead. Okay, so the one on the right, I'd first look here and I'd count 1, 2, 3, 4, 5, 6, 7. There's 8. So this is going to be oct. Oops. Octene, because that double bond right there. And when I have a double bond, I want to give that priority. So if I number this way, this would be carbon number 3. If I number this way, this would be carbon number, what was that, 5. 3 is less than 5, so I'm going to number from left to right. So that is carbon number 3, so I'm going to have 3-octene. and then I'm going to look and see that I have 4 of the same group. Again, 1 carbon, we're going to see this one a lot, is a methyl group. So I have methyl. Because there are 3 of them, this would be trimethyl. And they are on carbon number 2. This one's on carbon number 2. And this one's on carbon number 6. So I would actually put 2, 2, 6 trimethyl. We do put the 2 twice because there is 1 of them on 2, another one on 2, and 1 on 6. So there's kind of a complete review of what we did yesterday. Now we're going to kind of do some new stuff. Again, we'll go over this on Friday if there are still questions on it, which I'm assuming there will be. But hopefully you turn to page 7 in your notes, and we're just going to do just this one page. There are 6 different groups we're going to look at that have oxygen in them. The first, the name is an alcohol. Now an alcohol group is simply an OH attached somewhere. It's a hydroxide group. The way we name it is that we put OL at the end. So instead of like ane, we actually drop the E and we add all. So it'd end in like enol. If it's ene, we drop the E and be enol. In our class though, we pretty much won't mix double bonds, triple bonds, and oxygen groups together. So if right here it says draw 2 butanol. Bute, obviously, 1, 2, 3, 4 carbons. And then 2 tells us where the all is. So I'm going to go to carbon number 2 and I'm going to put an OH on it. That's it. Then I fill in the bonds to the hydrogens. Like before, feel free to pause anytime to name. This one down here, I see that the parent chain has 4. So this is going to be bute again, an, because single bonds. And then if you look here, which way should we number it from? If I went left to right, it would be 1, 2, 3, 4. And the 2 on the right would be 3 and 4. If I went from the left, these would be 1, 2, 3, 4, which is what we want. We want these 2 carbons where the OHs are to have the lowest possible. So this is going to be from the left to right. And so the way we would actually do this is because we have 2 alcohols, it would be butan diol, kind of like we'd say diene or diine if there was 2 double or triple bonds, and they are on carbons number 1 and 2. So 1, 2 butan diol. Just some examples there, but the big idea here is that an alcohol is an OH group, and we end it in all. Moving on, we've got something called an aldehyde. An aldehyde is what we call a terminal group. If you think of like a plane terminal or a bus terminal, it's at the end of the line. So it is always at the end of a carbon chain. So what an aldehyde looks like, it's at the end, the very last carbon, and it's got a double bonded oxygen and a hydrogen. That's it. So basically it's a double bonded oxygen at the end. The way that we name it is we end it in al. So similarly, instead of ane, we would cross off the E and say like anol, or ene would be anol. So here, heptanol, okay, the hep tells us 7. 1, 2, 3, 4, 5, 6, 7. And there's no number on it because we know it's at the end. Either end doesn't matter, but that is by default carbon number 1. And that's it. We fill in the bonds for the hydrogens. And there we go. If you're going to try to name the one on the bottom, you can see our parent chain has got 3. Go ahead and pause it and see if you can figure out what this would be named. Don't forget the chloro group there. But we got those 3. It's going to be prop, and then propane, because they're all single bonds. Propanol, because there's an aldehyde. We actually don't need to put the number, because that is by default carbon number 1. This will be carbon number 2, carbon number 3. So then the only thing we need to add is this chlorine. So this would be 2-chloropropanol. Propanol. Not all. All sounds like an alcohol, sorry. And that is an aldehyde. Again, important thing. Aldehydes are terminal. They look like this, and we end them in al. Next one, we've got another terminal one. It's called a carboxylic or an organic acid. It's also terminal. What it looks like is there's a carbon on the end. It's also got a double bonded oxygen, but instead of an H, it has an OH. The way we would name it is we'd end it in oic acid. And there is a space there between oic and acid. So instead of putting like ane, we drop the E and it becomes anoic acid. So that'd be like methanoic acid, pentanoic acid, octanoic acid, something like that. So if asked to draw pentanoic acid, well, that's easy. We just got 5 carbons. We know it's terminal, so it's got to go on the end. Again, either end is fine, left or right. And we fill in the single bonds. Pentanoic acid. Go ahead and pause and see if you can name this last one. Keep in mind that this one's on the left. This is going to be carbon number 1 by default. 2, 3, 4, 5. So I've got pentanoic acid. This is a methyl group on carbon number 4, so we'd say 4-methyl pentanoic acid. Okay, I'm running out of time on my program here, so I'm going to see if I can zip through these last 3 and 4 minutes. Feel free to pause, like I said, anytime. A ketone is just a double bonded oxygen, but it is not terminal. So it's a double bonded oxygen that we see somewhere in the middle, and we end it in -one. So instead of saying ane, we'd get rid of the E, pentanone, hexanone, propanone, something like that. So if you were going to draw 3-hexanone, well, it's a hexane with a ketone on carbon number 3. Hexane is going to be 1, 2, 3, 4, 5, 6. There's my ketone on carbon number 3. And go ahead and pause it and see if you can fill in the hydrogens correctly. Oops, I forgot one. Naming this one here, I see my parent chain is 4. So bute, and like ane for single bonds, butanone, and it is on carbon number 2. So I've got 2 butanone, and then I look at this group. This is not one we spent a lot of time on yesterday, but this is an amino group, and it is on carbon number 3 in this case. So I'd say 3 amino 2 butanone. Okay. Last 2 are a little bit funky. Make sure that you catch this, that ketone is a double bond, it's not terminal, and we end it in -one. Not one, it's -one. And ether, if you look at that name, that just looks funky. And ether is 2 chains with an oxygen in the middle. You can kind of see in this example right here, we've got 3 carbons on the left and 3 on the right. The way that we name them is we use those prefixes, the carbon prefixes, ol, blank, ol, another prefix, ether. The one that goes first is the long one. The one that goes second is the short one. So it could be like hexyl propyl ether or propyl methyl ether or something like that. This example here, we see eth, which we know means 2, meth means 1. So we're going to have 2 carbons. There's our oxygen in the middle. So those 2 on the left, that's our eth, and then 1 on the right. Ethyl, methyl, ether. There's the ethyl, there's the methyl. See if you can name the one on the bottom. Note that there are 3 and 3. This would actually be, because they're the same, you could say propyl ether, or you could say dipropyl ether would be acceptable as well. So this is always an oxygen in the middle. We name it like this. It's kind of a weird naming convention, but you're going to have an oxygen in the middle with a carbon chain on either side. Very last one is what we call an ester. An ester is similar, but you can see here it's got a double bonded oxygen next to it. The way that we name them is blank ol, blank NO8. And the chain that goes second is the one with the double bonded oxygen. So for example, if I look at methyl propanoate, it's going to be a meth, which means 1, prop means 3. Methyl means there's my 1 carbon, and then prop is 1, 2, 3. And because prop was second, I'm going to put the double bonded oxygen on this carbon. Go ahead and fill in, and you're done. And ironically, that's actually the same as this one. So that's methyl propanoate. There's 4 there. So this would be methyl for this side, and then the other side would be bute NO8. Okay, so I know that was fast, even though that was 15 minutes. We will go over it on Friday, but do your best, help each other out, and I'll see you guys tomorrow.